We are live. Welcome to tonight's meeting. I have finally got these times and everything adjusted correctly. Don't mind my dogs. So tonight I want to go ahead and start with, does anybody have any opens? No opens from anybody?
So I guess I was going to ask maybe Guo or Ravi, any queued up UPL changes you want to revisit here? Or I think we talked about maybe having intermediate spec bump ahead of the .9 and 1.0, or any of that on the horizon?
Yeah, for the universal payload, as we discussed before, we already submit a patch to use the Scalable interface as instead of the hub. That patch is, I mean, we will add like future maybe interface or call it open. So we didn't get much comments on it from community, so we can still use the hub as long as we get more comments to support the Scalable, and especially it is accepted by community. We can use that one instead of the hub. Currently, we can keep the hub as is. That's for the spec update. Another one, we are still working on the feature interface for the security feature interface, measured boot, secure boot. We want to define a standard interface. Firstly, we are trying to do a POC with Slim boot, and also make sure it works with the EDK2 bootloader also. Once that one is completed, we can present that change lately in this meeting. Yeah, except that I didn't have any other topics. Yeah.
That makes sense. And yeah, we still have that request to look at CBOR for FSP, and I think that one's still in the air. So okay, so it sounds like there's no immediate need to present something in the plenary here. We can work through the patch review, and looks like you're working on a measured boot interface, which probably leads us directly to the main agenda tonight, which is USF and security. So that's a good setup for G1 here.
Yeah, it actually really is. So if there are no other opens, going once, going twice. Okay, I will turn this over to Jaywin now, who is going to talk to us, give us an in-depth talk about security.
Okay, thank you. Can you see my screen?
Yes.
Okay, let me. Yeah. Okay. Today I would have a brief introduction for the USF security. Basically to cover two topics. One is a security solution, and another security assurance. I think most of the materials are available on this public repository. So first, for the security solution, the most important thing is the firmware resilience. We need to consider the three area like protection, detection, and recovery. On protection side, we believe the system firmware need to perform some critical resource lock like SMRAM, flash region, MML bar, etc. Then the service should be closed if we exit some platform manufacturer or state, like stop SM driver loading or flash update, etc. Firmware update need to be protected because they need to perform the authenticated update, anti-rollback, no bypass, etc. Secure data update should also be protected. For example, the authenticated variable either consider secure policy database One thing we noticed recently is about the forbidden database. Currently, we are using forbidden database in UEFI spec, but the Linux team raised some version number concept to see if we can have a better way to resolve that. Other things related to protection, one is the IMU-based DMA protection to prevent the ROG device attack the system memory. And another thing we recently see is the PCI Express IDE feature. It is a new feature added in PCI Express spec to 6.0, which is published end of last year. So this can be used to establish a secure link between host and device in case some secret message need to be transferred to the device.
So J1, for our other SPI and I2C buses, are there any other integrity data encryption? I thought SMTF or DMTF was doing a standard for the slower buses as well, right?
Yeah, DMTF SPDM spec as I will mentioned in the previous in the following section. For other buses, sure you can use SPDM to create a secure session. The software need aware of this secure session and set up the key. But for the IDE, the SPDM is used to establish the secure session to pass the IDE key. So basically, those are two different concepts. SPDM establishes a software link, and IDE create a hardware link.
Okay.
Hardware encryption.
Well, I was asking if there was any hardware data encryption for the. I realize the SPDM is software, but do we have any hardware based?
CXL. Yeah, CXL will definitely have that, but
okay.
this is not published. Oh, I see.
Okay.
CXL 2.0 already mentioned they have IDE, but there's no detail. I believe in 3.0 they will add the more detail for CXL version IDE.
Okay.
Then so the protection, some of the protection feature only resist the system software attack, like OS variable. You cannot let somebody in OS kernel to update the variable. But if you consider the attack from a hardware perspective, like hijack the SPI bus or something, it is still possible. So we need a detect feature again to resist the simple hardware attack. For example, the secure boot is a way to verify if a bootloader has been changed or modified. Then the data integrity, variable data integrity check is also a big feature. Like recently in the staging tree, we have seen the protected variable feature that can ensure even the simple hardware attack to modify the variable offline, it can still be detected at next boot. And the next thing is the SPDM protocol-based device authentication, which means currently you can attach any device, and the device may be malicious. It's one you don't want to attach. I think that with SPDM you can authenticate to see if the device is approved in your security device policy database. The last area is recovery. Once you have protection, you have detection. Maybe you may detect some error. Then you probably want to recover the system from the error state. A watchdog-based recovery triggering is a desired solution, and but the challenge is that probably you don't want to boot the current image. Then you need to boot a non-good image. Then a big question is, where do you put this non-good image? Make sure it is updatable and has some anti-rollback protection. So some of the work is done by the platform root of trust. Basically, you can put two system firmware in flash region and let the platform root of trust to detect this error and jump to the recovery region. if the main flash is corrupted, or trigger some update process to replace the bad image with a good image. Currently, there's lots of working group working on that. First, NIST have the firmware resilience guideline, and they also provide the bias protection guideline. In TCG, there's a CIRES working group and define the specification on how to build the CIRES IoT to support those protection, detection, and recovery. The standard is ongoing.
Given question on the detection part, if you before. So
Yeah.
you say resist a simple hardware attack. So the definition of hardware attack is somebody connecting a DDPROG and writing something to the flash.
Yeah.
Okay. So one open we had is about the MRC training data that gets saved in the flash during runtime, right? So
yeah.
Is there any consideration on how to protect that against simple hardware attacks?
Oh, you can. So you can only detect if it is modified. But you cannot. It's hard to prevent it being attacked.
But
So
MRC training data is not signed either, right? It's just a simple CRC at the maximum.
Oh, CRC equals to nothing. So are you? So is your question is how you detect the MRC data is modified?
Yeah.
Is that okay? Currently no. But with protected variable, yes, you can.
Okay.
Yeah,
That's why we have
Yeah.
this new feature.
Yeah, I think that's the big thing of if it's just stuff we write to SPI, even if we do like logically locking, there's an offline attack. So that's where you need something outside the SPI, like RPMC and some other verifier, those protected variables. Yeah.
Yeah. So basically, you can have two mechanisms. One is use RPMC and another use IPMB. But IPMC still use a SPI flash. It is I guess it's cheaper. So there's a monotonic counter in this variable. So whenever it is updated, we need to update a monotonic counter. And it is only you have some HMAC key, then you can update this counter. If you do an offline attack, you only modify the content in the SPI flash region, but you are not able to update the monotonic counter. As such, in next boot, it will be detected.
And you have to remember the counter value somewhere so that you know, okay, so this value modified, or maybe we can take it offline so that
Yeah, I think
the implementation.
I think we could share out like the link to the protected variable Jiwon mentions. It's on
Right.
Yeah,
Okay.
and you're right. You need like extra hardware to hide the MTC value. Because
I will put a link there so you can click. Finally, when I upload that slide. Yes, a very good question. I just forgot to provide the link.
Thank you.
Okay, next part is measurement and attestation. This is another things that is important because in firmware resilience, you have the great feature to detect or protect, but how the other people knows this detection or protection mechanism is enabled, right? We need to return those information to the verifier to attest to verify if the system has been enabled the expected protection. So here first we define two categories of firmware. One is the type 1 firmware. It includes the system firmware and PCI option ROM. So the definition is a firmware executed in host CPU. It's treated as a type 1 firmware. So we need to follow the TCG PFP spec to measure the image and data. a big question is completeness, that all the image should be measured, or the secure configuration should be measured, and that to ensure it can be verified later. And the second category is a type 2 firmware. We call it non-host firmware, device firmware. It is executed in a non-host CPU. For example, the CSME or a device firmware in a PCR card. It's run in their own execution environment, not the host IA CPU. So we are adding those featuring TCG PFP spec to measure the device, which if it is involved in the boot path. But care must be taken that not all device firmware can be measured by the players, because some device firmware may not have a hardware link to the host CPU, so it may not able to be accessed by the host IA. And some of them are attested by the platform active root of trust, like Intel PFR or the Microsoft Cerberus or Titan chips, etc. Those platform root of trust can verify those device firmware as well if they want to. So, and we are following the NIST spec, the bias integrity measurement guideline on the TCG platform film spec. And recently we are doing lots of work for the confidential computing, like the hardware TE based, including Intel TDX, AMD SCV, or RAM extension. So that we are delivering the virtual firmware for the confidential computing extension. This is a new spec section we submit to Bugzilla. Hope this will be appearing next UEF or ACPI standard. So there's a very important concept that the initial of the virtual firmware is measured by the trusted hardware or software, such as Intel TDX module or AMD PSP, and those components can provide the measurement of those components for the remote attestation, and the rest of the component will be measured by the initial virtual firmware. So by using the remote attestation, the verifier can know how the virtual firmware is. Also, so what is the content in the virtual firmware and how it loads the next component, such as OS loader, OS kernel, etc. And this is a big change for the existing threat model for the virtual firmware. Currently, without confidential computing, everything from VRM is trusted. But with confidential computing, VMM is out of TCP. So we need the keycap for the VMM input. It is not trusted. The basic principle is that you need to measure the input from the VMM and ensure it can be verified by other people. Then the next topic is the crypto agility. So currently, different standards provide the minimum requirement for crypto algorithm. Like the CNCA suite define the minimum set is SHA-384 at ISA PSS 3K or ECDSA P384. There are some other standards. It's different lower, like a PRC CESA server bias requirement. They still the minimum requirement still SHA-256 or RSA 2K. Or ARM trust boot requirement. They require the ECDSA 256 or RSA 2K, but PSA for M profile, they define ISA 3K. Yeah, it's a little weird. Then the OCP secure boot, they define the minimum requirement aligned to the CNSA suite, that is SHA-384 plus ISA 3K. But unfortunately, the UEFI or EDK2 currently only support RSA 2K plus SHA-256. That means we cannot meet the minimum requirement on the CNSA. So as
That's only in the code though, right? It's in the spec. You can have SHA-384 512. I think I remember we used to have that in the spec, but we just didn't code it that way since there was nobody at the time when we launched Secure Boot that was using SHA-384 and 512.
no, I don't think so. So we just submit the issue to remove that algorithm. So in current standard, like the UEFI 2.9, it said the PK is the size of PK is 2K. As variable, you need to use RSA 2K. There's no way to use other algorithm.
Oh, I'm sorry. That's for the measure boot, not for Secure Boot. Yeah, that's right. Sorry.
Right. That's why we submitted Bugzilla to separate the crypto algorithm from the main spec. We put a standalone section, and in the future we only just need to update the standalone section. And as following up, we support multiple crypto algorithms. So basically, this ECR some can support a new algorithm with compatibility configuration. 3 new variables are defined. Crypto indications allows the OS to request the crypto algorithm to the BIOS. Then the crypto indication supported means the firmware need a report what is the algorithm supported to the OS. And the crypto indicator activated means the firmware report what is the current used crypto algorithm to OS. So the basic usage during boot, firmware collect all the supported and report and consult the OS the crypto indications to activate that. Then at runtime, OS can check. The OS can check if it is good enough. If not, the OS can set crypto indications and then reboot the system. Beyond that, I also noticed that post-quantum has some new requirement. If the productions need a EOL after 2030, we may consider the post-quantum crypto algorithm. Currently, it's approved to state for hash-based signature. It is mentioned in 800 to 208, and we consider the hybrid signature mode, which means you pick up one existing signature, such as ISA or ECTSA, and you pick up another post-quantum signature, XMS or LMS, and you can buy them. And the verification code neither pass the traditional signature verification and the post-quantum signature verification. Only after both of them pass the verifications, then you can say, okay, I approved this signature. If any of them fails, then the verification fails. This is a new feature we can consider later after we supported the crypto agility. Then the next is the security assurance. There's a lot of assurance technology we can use. Break them into 4 categories. The first is the tactics. The first, we try to eliminate the vulnerability. If there's still some vulnerability there, we try to break the exploitation at the runtime. If the exploitation is not broken, we try to contain the damage in a limited scope. And if it is still broken, we try to limit the attack window by detecting this issue as soon as possible and provide a fix as soon as possible. The example of eliminate vulnerabilities, the first example is obviously we need to remove unnecessary interface, such as all the SMI handler can be treated as an important attack surface. We're trying to limit that and remove all the unnecessary one. And UEFI variable is another perfect attack surface. If you don't need to save it into non-volatile storage, then we should not do it. Good practice should always be followed. There's lots of document in indicative security folder and the OCP security docs. People can refer to that. Side channel attacks is a very new and recent attack since Spectre and Meltdown. Lots of attention is put there. The last category we may consider to use a Rust programming language because that is type safe. It can prevent you suffering from the memory safety issue. Break exploitation is another big category. So there's a couple of technologies. First is data execution prevention, then the control flow guard or ASLR. Those are very classic prevention mechanism. For data execution prevention, we can set all the data page to be non-executable and set code page to be read-only. As such, nobody can inject any code with that protection. Stack cookie is a software mechanism can prevent the backward control flow. Intel provides CET like shadow stack or IBT to support the control flow guard. And ARM, they also have the PAC, point authenticated code, and a BTI to support the control flow prevention. Then the ASLR is a mechanism to make the attack harder, so you cannot predict the location of the target. For example, if you can modify some data object with ASLR, you probably don't know where the object is. Contain damage is a way to limit the attack in some scope. A common mechanism is to deprivilege. For example, we can deprivilege the third-party option ROM from ring 0 to ring 3. So if the option ROM is malicious, it cannot modify some system memory content. Then the ring 3 OEM SMM is another way we can deprivilege that. This is a feature enabled in Windows Secure Core PC. The last has a limited attack window where you can support live patching runtime component. So if you're running a system and found some code has some vulnerability like SMM, you can patch it, or runtime service, you can patch it. Then the firmware vulnerability scan is another way. If somebody reports some firmware has vulnerability, you can scan to see if your system has a similar vulnerability. And there's some last risk item. I'm trying to write a shareable common code. Example is the SPDM. It provides SPDM stack implementation to the reusable in EDK2, BMC, or operating systems. Like the OpenSSL, it provides some common code to implement the security protocol, so other people don't need to spend time to reinvent the wheel to implement the same thing again and again. So if only one code base reusable, we can just focus on improve the quality of this particular code. There's a lot of eyes can be put to improve that code. When we develop this libSPDM, we receive lots of feedback from different company or even some university, include Brazil's Sapporo University. They provide some good unit test cases, and another university is collaborating with Intel to do some formal verification, and they find some interesting bug, and we fix that. So basically, if we try to support a universal payload, I think this is a goal we want to achieve to ensure the component we deliver can be run in multiple different environments. Okay, that's all for my presentation today. Any questions?
Yeah, no, thanks, Ju. And this is, I think, really exhaustive and
Yeah.
coverage. I was curious your thoughts. I know early in this effort when we talked about like some of the supply chain stuff and the FIMs, we ended up branching out the measurement and FIM creation guidance to like an FSP specific document we homed on the FSP homepage. But if you think about tracking assets, do you imagine a world where that same methodology could be used to track like, universal payload binaries, whether a Linux boot or an EFI? And should we provide any guidance in the main USF document around one, creating manifests for binary assets, and then secondarily, there seems to be a lot of motion on SBOMs and other things, i.e., your source code repositories, how you do supply chain. So I guess what are your thoughts about moving FIMs into USF more generally, and any thoughts on any touches we might need to do for SBOM accommodation?
I think that's an excellent question. I would think if the universal payload can be adopted in multi-environment, we definitely need to provide the SBOM mechanism. I think as first step, we can just enable the TCG trust boot to let the loader measure. I think there must be some loader to measure the universal payload, right? So the measurement data we can provide with a RIM. So currently there's a RIM or a co-RIM style manifest. I could imagine if the universal payload reached some production quality space, we want to release it, then we can not only release the binary, but also release a corresponding RIM file. A RIM means a reference integrity manifest to describe who created, what's the expected hash, etc. As such, if other component like EDK2, if you want to load the universal payload, finally put to the system, then the verifier can see what the content there. If it loaded the latest universal payload, if it match the one published in the universal payload website, I think definitely we can provide those information.
Okay, so he's adapt the RIMs, the same tools that maybe we were looking at for other binary objects like FSPs would probably forward applicable to the universal payload object.
Right.
Okay, that makes sense.
Right. And then currently what I know is in IETF, there's a standard, there's a draft for code suite. It's already in 21 version. I think it's quite mature. We can use that as our initial phase, definitely. And another manifest named the co-RIM. Co-RIM is a superset of a code suite and a commit. They consider both the software component and the hardware component. If you want to add the device measurement from the hardware component, they definitely want to choose the co-RIM. But for the software component, it can be the co-RIM is a wrapper for the code suite. But that's code RIM spec. It's still very early phase, like version 2. I believe there will be a long way to go. So as initial phase, well, I think what we can since boundary is the same, it's just the format of the RIM, right? So what we can provide is one a support RIM following TCG existing PC client RIM spec. We can provide the expected TPM measurement and event log. And second, a code suite style manifest to describe this measurement, just in case some verifier want to use has preference use a code suite, and it exists today. And for future, we can provide the code RIM style manifest to let people try and feel what the code RIM looks like.
Gotcha.
Those
It's a data that's an adjunct to the binary. The binary is still the same, but these are just evolving metadata formats depending upon what the market or the verifiers want. So we can grow as the format as or track whatever market's using. Okay, no, that makes a lot of sense.
Yeah, exactly.
Hey, Jimmy, it's John. Literally, I'm working on Chrome on the Kobo side, and literally, as you know, like Kobo, we have a kind of dependency on the FSP, and also we have a goes to another part we call the payload. Literally, right now we call the depth charge part, and so at that moment, it is possible. I mean, I don't know how much effort you've done there on the working on the universal payload. So maybe it's possible. Maybe moving forward, we can share with us, like any source code or any document. I can, we can study for that. So so far, I just briefly looked at your slide. You mentioned like kind of security. I think you mentioned like MMU stuff, and or some some other part. Literally in the Kobo side, probably as you know, all those features is not down the payload. There's like stuff like not in depth charge. Typically for us, we have kind of be exposed to the VTT stuff or the DMARC table to the kernel. That's pretty much how we do that. And beyond that, some of the IP, the security issue, like for instance the Type-C stuff, right? So literally the CSE, they authenticate it, and then further on they can load to the MR. So in the boot time in us, we check it's valid, authentication being done by our CSME stuff. Then later on we can present to the kernel. So I would say there's a multiple place and the different scenario, different devices or IP to regarding for the security part. But at the moment right now, and I probably were more kind of more interesting, and try learn or align with what you just described from the briefly on the universal payload. Because so far I'm not so sure how much like a security part could be or implement in the payload stuff. Yeah, so that's I don't have any kind of questions, like try to understand to learn that. Yeah.
Sure, that's an interesting topic. So, Vincent, do you know if Kobo can launch the universal payload at this moment?
Yeah, I think there's some developer trees that have done the adaptation. I don't believe it's been upstreamed yet. I think one of the questions about upstreaming was that Hob to a self-describing format, but we do have a developer branch, and I believe even in the files section of the group IO, there was a breakout session on core boot and UPL. I can point you at, and I think so we can definitely. But I think you bring up a good question that probably, I don't know if it fits the main USF spec, but would be a good audit of USF is like of at least the 3 bootloaders we're looking at, Slim Boot, Core Boot, EDK2. What defenses do they have? Where do they match this? Things like this crypto agility. Where are the verifiers? Because we want to have as much consistency as possible, and having that sort of chart with all three bootloaders next to each other, I think would be valuable to have these sort of comparison discussions you're asking about. But yeah, we do have we just the UPL I don't believe is on the core boot upstream yet, correct, Guo?
Yeah, we previously did a patch to change the carbon directly to support the universal payload. That patch is not really accepted by the corporate community. So we developed a stream layer that is like a corporate payload. With that stream layer, it can boot the universal payload. Yeah, that's the current solution for the corporate to support the universal payload for now.
Oh yeah, would you mind in the share some the link? I'm kind of interested to follow up to study for that. So it's kind of be my understanding right now, right? So like and the core boot is part of. I mean the depth charge is kind of used to be similar on the on Google side. There's just U-boot, whatever they give the name, the depth charge whenever they have expensive stuff. So literally that's part of on the core boot, the image report. So you do have a separate the community on depth charge itself. So like what you mentioned, I mean, you do some working on the Cobus community. I'm not so sure what you mean for that one. So literally that'll be very interesting. You can share just the document link or the source code in our end. I mean, we can follow up to study for that to really how we can adopt to the USF. I mean, universal payload, those kind of concepts.
But yeah, no, I think the depth charge as a UPL payload, definitely I would like that. And then even, classic U-boot as a depth charge, or excuse me, as a UPL payload. Because yeah, the concept of the UPL is kind of normalizing the interface so that you could run these payloads on top of any bootloader, core boot, slim boot, EDK2. And so yeah, depth charge is, supplanted U-boot in the Google products, but some vendors still do use U-boot as payloads. And so yeah, I think that'll be a good technical follow-up. We can provide some insight into the depth charge community and applicability of the UPL. I think it sounds like a good follow-up.
Okay, and actually it's new to me, so that I would like to learn it, to understand so how we can adopt it, apply this kind of concept to the Chrome product. Yeah.
Yeah, literally I can send you some link with the POC and the for what we did based on the carbon.
Yeah, please.
Yeah, I think I got a similar question from Pratik on that team, and yeah, a few days ago, and yeah, definitely really like to collaborate on assessing UPL and depth charge. So yeah, I think that's a great.
Yeah, with the same team, pretty.
Oh, good. Okay.
Yeah, so
Good.
Yeah, another question, Yawen, basically we are trying to also standardize the interface between the bootloader and the payload, right, for the Scalable and the Measurable. So we want to keep the bootloader and the payload consistent, right? If the Scalable, for example, is enabled in the bootloader, we also want the Scalable is enabled in the payload. Similarly for the Measurable. So in this way, we need to pass this kind of information from the bootloader to the payload. For the Scalable, for example, besides the enable disable, we also need to pass some other information, right? For them, what algorithm we used in the bootloader, maybe 3K or 2K like that to do verification. But do we have to keep them consistent for this kind of details? Or the payload and the bootloader, they can do their own, since we want to make them also standalone,
right? My personal opinion is we should try to be consistent as much as possible if we can, but we should be flexible. like to make so the basic requirements, we should not be the weakest link. I mean, the user, if everyone use 3K and we say we only support 2K, that becomes a problem. But if someone say I support 4K, someone say I can only support 2K, then we're trying to maybe align the secure one, but not the weakest one. I think that probably is good enough for us.
So for the bootloader, for example, it can support RSA 2K and RSA 3K, right? Whatever their bootloader selected, maybe they can pass this kind of information to the payload. So for the payload, from the payload viewpoint, they can take this information as a reference, or how do you think the payload can use this kind of information?
I think just use as a reference. The only thing I'm not clear is, do you want to reuse some policy database? Means
No.
allowed list or denied list.
No.
So you want the payload keep its own policy database, right?
Yeah.
If that is the case, then it is not so important. Maybe just tell you the algorithm should be enough.
Okay.
Because at current point time, already seeing the diverge from the different components, like the CPU microcode may support a stronger ACM, maybe it is support stronger, but the UEFI is about weaker. Then the shim may use a different algorithm. Then the payload, you definitely can use a different algorithm.
Okay, just like the capability, whatever their bootloader supported or they used, just provided this information. For the payload, they have their own choice based on this information.
Right.
Yeah. Okay.
Right. I would say meet the minimum requirement from the standard, like CSNA, that is a 3K plus SHA 384, CNSA, and the OCP secure boot requirement. It said the same thing.
Yeah.
I think that's good enough. We can definitely predict the future, for example, to support post quantum, but I'm not too worried about that, because since we are the software company, it's easy just to update it in the future.
Okay, thank you.
And the measurement is another thing. If the bootloader supports the measured boot, they record everything. Then the payload, I believe, it should also support measured boot. So it's need to record the policy database and how you verify.
Yeah, measured boot may be a little different. They, especially the TPM, right? When you extend it to the hash to the TPM, maybe you need to keep them consistent. If not consistent from the OS viewpoint, I'm not sure it would like have issue maybe.
Right. Not only PCR but also event log.
Yeah. So there are multiple maybe the bootloader, they can even support two mechanisms at the same time, right? From the payload, maybe they can select one of them like that. But at least they should keep assistant from my viewpoint.
Wow, this has been a great discussion, everybody. Thank you, Jae-Wen. That was a really good presentation. Will you send that to me so that I can post it to the USF site?
Oh, sure, definitely. I can post it by myself.
Okay, yeah. If you'll post it up there in the file section, that would be great. I will post today's video recording up there also for anybody else. I did want to ask Vincent if we have any ideas for future topics.
Yeah, I think a couple come to mind. We had ARM present on their handoff proposal. We haven't double backed with those folks, and so that's kind of a, maybe revisit them with that topic. So that was kind of their proposal, if I recall, was very Hob-like with a unique data encoding. And then of course we have CBOR, which is, instead of Hobbs, a more self-describing structure. I think that whole topic area we need to revisit in status offline. And then I was thinking these first tranche of meetings were kind of reviewing the USF spec. I don't know if some of the platform features, like I think Sai had created some of that content, if it makes sense to review that in the same spirit as Jiwon's reviewed his area. So those are a couple possibilities.
I think that's a good idea.
And then I think we'll definitely work offline with the depth charge folks about applicability of UPL to these other payloads. I don't know if that'll merit a meeting topic, but definitely we've taken action to work with John and folks on that. But yeah, I'd like to, in the spirit of openness, anything that's written in the USF spec have the principals who created content review it. So
Yeah,
that's
would be great.
probably the prime candidate. I was thinking about it this week, but
Okay,
yeah.
I will get back to you sometime this week and discuss it with you. I think we have a one-on-one later this next week, so.
Oh, great. Okay, sounds good.
So is there any other things anybody would like to bring up and discuss right now? If not, we did this absolutely perfectly. It is 8:28 and I am going to stop recording.